Hey there, CJ Math students. You're on page 351. So Hiroko is trying to find the value of d, and 10d plus 490 equals 2,500, right? So to do this, you would subtract 490 from both sides and then divide by 10. However, he starts off by taking out 10 from both sides and getting this, which is still a reasonable way. Why? Because if he divides by 10 on both sides, the 10s cancel out because 10 divided by 10 is 1, and 1 times anything is just that thing. So d plus 49 is equal to 250. And now he's just asking himself, what number plus 49 is equal to 250? Well, if I see addition, I subtract from both sides, and d is equal to 201. Number 2, Gavin says the hanger diagram shows that 2x minus 4 is equal to 8. Is the same as 2x equals 4, where Jabari says the hanger diagram shows that 2x equals 12 is the same as 2x minus 4 equals 8. Who is correct? Well, let's think about this. 2x minus 4 equals 8. So if I have minus 4 on both sides, I'm going to need to add 4 to both sides in order for these to become 0. So 2x should be equal to 12, so Jabari is correct. And let's think about mathematically why in this hanger diagram. Notice here I have negative 1s, and over here I have positive 1s. So I can't simply just cross those off because they're not the same exact thing. So I need to be able to add 1 to both sides, or add, in this case, 4 1s to both sides in order to keep that hanger diagram equal. If I wanted to solve, I would just divide by 2 in the end, and x is equal to 6. Explain the reason about the value of y in 1/2 times 2y plus 4 is equal to 14. Lamont and Serafina each rewrite the equation. Lamont rewrites the equation as 2y plus 4 equals 28. Serafina rewrites the equation as y plus 2 equals 14. Explain each person's strategy. So we're going to explain Lamont's strategy, and we're going to explain Serafina's strategy. Let's start with Serafina first. She's a little bit easier. 1/2 times 2y plus 4 equals 14. Serafina simply distributes, right? 1/2 times 2y, half of 2y is just y, half of 4 is just 2, is equal to 14. So all she did was use the distributive property. When you subtract by 2 on both sides, you go ahead and get your answer of y equals 12. Now, Lamont's strategy is a little bit different. Lamont is saying, I want to isolate this 2y plus 4 equals 14. So to get rid of that on both sides, he multiplies by 2 over 1. 2 times 1 is 2, 1 times 2 is 2, 2 over 2 is just 1. So 14 times 2 is 28. So that's how he comes up with 2y plus 4 equals 28. To solve this, first I see addition, so I subtract from both sides. I get 2y is equal to 24. Now I see multiplication, so I divide. And I get y is equal to 12. Both end up with the same exact answer. Consider the following equations. W plus 4 equals 25, 3x plus 4 equals 25, and 7y plus 4 equals 25. What must be true of all the values of w, 3x, and 7y? Well, let's simplify these all by subtracting out 4 from both sides. And when you do that, you get w equals 21, 3x equals 21, and 7y equals 21. So they all end up equaling the same thing, so they all must be equal. Now, that doesn't say all the variables are equal. It just says all these equations are equal. So which one will have a greater value, w or y? Well, w is equal to 21. It literally says it right there. And y, well, 7y equals 21. Well, to figure that out, just divide by 7. 7 divided by 7 is 1. So y equals 3. So which one has a greater value? W is the greater value. And now it says, lastly, order w, x, and y from least to greatest. Well, w we know is 21. Y we know now is equal to 3. And to figure out x, just divide by 3 on both sides. So 21 divided by 3, x is equal to 7. So from least to greatest would be y, because that's equal to 3. X is equal to 7, and then w is equal to 21. Lastly, how can you reason about the equation 8b plus 3 equals 35 to find the value of b, right? So very simple here. First thing you want to do, you see addition, so subtract from both sides. So 8b is equal to 32. Then when I see multiplication, just divide. So b is equal to 4. You're saying what number times 8 plus 3 is equal to 35, or what number times 8 is equal to 32, and b is equal to 4. If you plug that back in, you should still get 35. Let's prove it real quick. Plugging in 4 plus 3 equals 35. 32 plus 3 equals 35. Yep, and on both sides, 35 equals 35. So we are correct. Close your computer. Ask for the exit ticket.